As we've seen, relational database management systems are very powerful tools for structuring our data. However, there's nothing magical about an RDBMS. Just like any other piece of software, there's nothing inherent within it that forces us to use it correctly. We could use MySQL, for instance, in exactly the same way as we use a filing cabinet, a card index, or a simple file structure. The process of normalization are a set of formal disciplines which allow us to make sure that our database systems get the most out of the relational database model. The best way to explain how the process of normalization works is to take a look at a very faulty database and then apply the so-called normal forms to this database and improve the database until it's fully normalized. I'm using the library database, but in a very crude and unscientifically formed format. If we take a look at the table definition here, there's only one table, the books table. That includes the title of the book, the name of the publisher, the number of pages, size field, which allows us to get an idea of the size of the book, and the year it's published, the name of the genre, and the author's name. Now, there are a lot of problems with this table and the way it's structured, but let's first of all take a look at those features of it that violate the maxims of the first normal form. To begin with, there's no primary key. We need a primary key for a table to meet the conditions of the first normal form. We need to therefore add a primary key, and we also have a problem with including the author name all in one field or one column. This is because when we come to run a search, for instance, and we want to search for Gibson, we will have a problem because we'll have to search on part of that column. This will be a very inefficient way of running any kind of search on that. So let's take a look at the first normal form version of this particular database. We still only have one table, but now, as you can see, we've created a primary key, and the primary key is on the title and the author surname. We've also split that author column into three columns: the author first name, the author initial, and the author surname. This respects the principle of atomicity, which is that each of the columns should be an atomic unit of data. That is, can't be broken down any further in the way that a full name such as William Gibson can be easily broken down into two names. There are still a lot of problems with the structure of this table. First of which is that the primary key is not, although it looks like a fairly safe one, Neuromancer by Gibson, is not of itself a unique identifier that could not, under all possible circumstances, be duplicated. We would be better off using the ISBN, which is the unique number that is applied to every book that's published. So we can incorporate that. Another far more serious problem is that we include the names of the publishers with every book. We're also including the names of the genres with every book. We're including the names of the authors with every book. So, although we may have 5 or 6 books written by the same author, we're going to have to store that author's name 5 or 6 times. This allows us to store the author's name spelt in a slightly different way each time, forces us to waste space, and allows for the kind of errors caused by duplication of data. It also violates the principle that a table should store information about one logical entity. Let's take a look at the second normal form of our database, and here we've broken it down into several tables. Now the ISBN has become the primary key, which is a much better unique identifier. The publisher column is simply an integer which refers to the primary key of the new publishers table we've created. The genre similarly has a numeric column there, and the author has been completely removed from the books table. Let's take a look at why. We have the authors down here. The authors have a primary key which is numeric, and the 3 fields have been shifted into the authors table. If we scroll down a little, we'll see that the bridging table, book authors, allows for the possibility of more than one author writing a book. And the primary key there on the book authors bridging table is book and author. The publishers and genres table have helped us to split the data away from the book table. And here we have an example of inserting some data into the tables in this database. There is one other problem with the table, the books table as it stands, and that is the size column. Now the size column is very useful because it allows us to, at a glance, be able to split all the books in our collection or our library into smaller books, medium-sized books, or great big epic books. However, we're also storing the pages column in the same books table, and the fact that the size of the book in terms of the length of the book is determined essentially by the number of pages means that the size column is basically dependent on the pages column. This breaks one of the principles of the third normal form. So when we look at our final version of the database, we'll see that the size has been removed from the books table. And we simply have down here a sizes table which specifies the different sizes according to a name, and then the lowest number of pages that go to qualify a book for a certain size. If we take a look at the insert statements at the bottom, the final 3 insert statements, we can see that we've actually entered the brief, regular, and epic along with their definitions, as in the number of pages minimum that go towards categorizing a book as that particular size, are included as data rather than hard-coded into the table. So we've gone through the process of taking the very brief and illogically ordered non-normalized table that made up the database in the first of these text files and taken it all the way to the several table arrangement of the database that fits the third normal form. There are other normal forms, but knowledge of these ones and the general principles behind them will suffice for basic database usage. In the next movie, we're going to look at some optimizations which you can apply to your existing databases or your databases as you're working on them in order to get more performance from your database structure.